Alright, here we go, guys. Today we got complex numbers and imaginary numbers is another word we're going to use a lot here. So not all equations have real number solutions. They're going to ask us to sketch this graph here and see what we notice here. So if we go graph x squared plus 4, we notice at 4, and you can check this with a graphing calculator, at 4 on the y-axis right there, that's where your vertex is going to be, so it never actually crosses your x-axis. So then when we say, okay, how many zeros or how many x-intercepts does this thing say? We've always said there are no, that we'd say there are 0 solutions, but really we need to say there are 0 real solutions. Okay, so even if a quadratic has no real solutions, it can be solved. To enable us to take the square root of a negative number, mathematicians created and expanded a system of numbers called the imaginary unit, and usually we use an I to write those. So we're going to talk about, these are the imaginary roots of the equations, or the imaginary zeros. And that's kind of looking into it here before I was making the video. A lot of electrical engineers actually use imaginary numbers to figure out certain situations and stuff like that. So it's heavily used in that field. Probably not in a ton of other fields, but I know there's a lot of calculus involved and everything. So we're just going to really just scratch the surface of imaginary numbers here today. So here's how you do it. If r is a positive real number, then the square root of negative r right here is going to be the same thing as if we put this little I symbol out in front and then the square root of that same positive version of the number. So like for example, if we have the square root of negative 3, we're going to say it's I and then square root of 3. And that's how you write out your different numbers there. Remember that you must take your i's out first. And that's a key thing here. That's actually going to help us solve a problem here in a minute. Now, just real quick, just so we can kind of see a couple things, especially these two here. These are going to be kind of helpful here. So we said I is going to be the square root, and since there's no number, we can say it's kind of an implied 1 here. We're going to say it's the square root of a negative 1. So if we have I squared here, this is like saying the square root of negative 1 times the square root of negative 1, which actually equals just regular negative 1. So one big thing is we're always going to say I squared is equal to negative 1 right there, and we'll use that quite a bit here today. Now, if you have I cubed, we can say this is the same thing as I squared times I to the first power, just using your power rules from Algebra 1. And then we can say, okay, well, this I squared piece right here, we just said that equals negative 1. And then times I right there would just get us negative 1I, or just negative I. Okay, so that's one of our other properties here. And then if you have I to the 4th, this is the same thing as saying I squared times I squared, which is the same thing as saying negative 1 times negative 1. So if we do that, I to the 4th becomes positive 1. And we'll write that out here to the left here. So these are all of your, different properties here about your I stuff right here. I guess over here on the left side is what they actually equal, and over here on the right side is, the work behind it there. Okay, so now you can actually go and continue the table. I wrote these in here. If you continue it here, I to the 5th is the same thing as I to the 4th times I right there, which I to the 4th we just said it was 1, so this is the same thing as just 1 times I, which is also just I right there. So notice I and I to the 5th, they come out to the same thing. And you're actually going to kind of see that across the board with I squared, I to the 7th, or I to the 6th, I to the 7th, and I to the 8th here. So you have I to the 6th right there. You can say, hey, that's kind of like I to the 4th times I squared, which is like saying 1 and then times, I squared right there. And then I squared, we already said was negative 1, so this will just come out to negative 1. So you can kind of go and cycle through the pattern here. Every 4 powers here, it cycles back through here to the same stuff that we started out with. So I guess I to the 7th, we can say it's going to be negative I, and then I to the 8th will be positive 1 right there. So that'll be kind of useful to solve a few problems down here, or simplify a few problems down there. So anyways, let's talk about how you simplify some of these. These will be more of the common problems we see. So if they say, okay, what is the square root of negative 36? The very first thing you're going to do here is you can write this step out. Some people will skip it here, but this is technically the square root of negative 1 times 36. And then we said the square root of negative 1 is I. And then the square root of 36, whoops, it's just going to be regular 6. And I guess you could write it kind of like this here. A lot of people are going to simplify it and say this is 6i. And most of you guys are going to get to where you just simplify it straight down to 6i right away. Okay, so if you have a number that's not a perfect square, we can just say, okay, this is I square root of 20, kind of like skipping a step here. So I square root of 20, anytime you see a negative inside, pull out an I. And then 20, we're going to simplify 20 and break that down. So you can say, okay, that's 4 and 5, and then 2 and 2. So we'll say this is 2 square root of 5, but then there's an I with it. So we'll write 2i square root of 5. Sometimes they'll throw in some I squared, so they, I guess, have already simplified the radical maybe. So anytime we see I squared, we need to get used to putting negative 1 right there. So I squared will always change to negative 1. So this will simplify to negative 9. Okay. Next one here. So this is the square root of negative 4 squared. Whenever you square a square root here, these essentially cancel out. And then this will be, I guess, negative 4 right there. Okay. All right. A couple other ones. This one's kind of a tricky one here because a lot of people are going to want to say, oh, negative 4 times negative 9 is, I guess, positive 36 here. But kind of like the one above, we're going to write this here as square root of negative 1 times the square root of 4, and times the square root of negative 1, going with the 9, and then times the square root of 9 right there. Now obviously 4 is, going to be 2, or the square root of 4 is going to be 2, and the square root of 9 will be 1. And then we got a few different i's here. So this right here, square root of 1 right there is going to be I. So that would be 3i right there. And then the same thing over here. This will be 2i for this piece right here. Okay, now 2 times 3 obviously is 6. And then I times I is going to be I squared. And then like the previous problem was saying, I squared will become, negative 1. So then we will say that this simplifies all the way to negative 6 right there. Okay. Right here you got 7 and then I cubed right here. So if we kind of use the idea from above here, we can say I cubed is the same thing as I squared and then times I. Okay, and then I squared we just said changes to negative 1. Anytime you see that, you need to replace I squared with negative 1. I guess times I. So that should be just negative 7i, and that would be fully simplified. Alright, let's see what's going on here with this one. So there's a couple of approaches we can do when we have I to the 6th right here. If we know our little pattern and how everything cycles through, we can say, oh, okay, I to the 6th is kind of like I squared right here. It matches up, so it's going to be negative 1. Now, another way around it, if you don't want to memorize that little chart, and if you don't want to memorize it, one way we can get around this here is change I to the 6th. If we can write that as I squared raised to something else, so I squared cubed right there, then we might be able to actually solve this out here. And here's kind of what I mean here. So I to the 6th right here, we can say, okay, if we do 2 raised to 3 right there, that's the power of 6. So obviously that matches up there. And then like we said, I squared, we can say it's negative 1. So that's negative 1 cubed right there. Negative 1 times negative 1 times negative 1 will stay negative. And then times negative 8 will actually make us a positive 8 right here. And that would be your answer. So a little tricky there on these, but I guess I to the 17th, kind of the same idea. There's two ways you can do this here. You can go through your cycle here. It cycles through every 4 powers. So if it cycles through every 4 powers, we can say, all right, well, if it's kind of like, I guess, think about division here. If you have 17 here and you're cycling every 4 here, well, 4 goes into 17 4 full times with a remainder of 1 right here. So we can say I to the 17th is very similar to I to the first power right there, because the power, when you subtract off of 4 a bunch of times right there, the leftover power is going to be 1 right there. So I to the first power, we said, was the square root of -1 right there. So we can either write it as square root of -1, or we can write it as I. I think most of the times we're going to write it as I in this case. Now another approach here, if you have a fill to end notes, they work this in a slightly different way here, so I guess I'll section it off here. One way you can do this here is think about I to the 17th is kind of like I squared a bunch of times here. We can say that's like I squared to the 8th power times 1 more additional I. Okay, and then we can think, okay, what's the -1 basically to the 8th power? All right, and then times the I. And then obviously -1 to the 8th power is an even power, so every even power, I guess, will cancel out the 2 negatives. So this will basically be +1 times I, or it'll just be I right there. And guys, these take practice here. These are not something that just comes real easy and natural. So just kind of bear with it, check the answer keys, and you'll get it down here eventually. I think that should be enough examples there to kind of get you going on those types of problems. So now that we've kind of talked about I a little bit, we're going to talk about how to solve a quadratic dealing with I. So like right here, we got this one right here. So one way we can solve quadratic equations, especially if we only have x squared, is we can isolate that x squared. So we're going to subtract over this 18. It's going to leave us with 2x squared. I guess that's negative 90. Okay, and then from there, I guess divide by 2. So that'd be x squared is equal to -45. And then before we said, oh, well, we can't really square root a negative number, so we say there's no solution. But now, since we're talking about imaginary numbers here, we can say that this is the same thing as I, and then square root of 45. And then we need to simplify and break down 45. We can say, whoops, that'd be 9 and 5, and then 3 and 3. So altogether, this will be 3 square root of 5 with I. So I'm just going to squeeze it in right there, and then that will be your answers there. Oh, and by the way, whenever you square root something in algebra here, if you square root both sides, we put plus or minus right there. So actually, I need to go add that in, and that's kind of a big deal there. We'll bust you guys on that if you only put the positive version. So make sure you put plus or minus when you are square rooting both sides. Okay, let's try out another one here. Kind of the same idea, I guess. This is 3x squared. Once you subtract 5, I'll get you -30. And then we'll divide by 3, and that'll get us -10. And then we'll square root both sides, and then don't forget your plus or minus. This will be plus or minus, and then 10 right there, or square root of -10 right there, we'll need an I. And then that'll be square root of 10 right there. And actually, if you go try and break down 10, you only get 2 and 5, and you don't have pairs. So actually, square root of 10 is fully simplified. So this will be your answer there for that. So look out for those types of problems there. The next little section here is about complex numbers. Complex numbers are combining, I guess, imaginary numbers with real numbers here. And here's how it typically looks like right here. A, we're going to always call that the real part right there. And then, A is like the real component. And then B can be a number, like a coefficient. But then since it has an I, that's going to be the imaginary piece of the number. So the number blank is always part of the complex number. So we can say the number B is always part of the complex number, and then, I guess that's supposed to be A here. Oh, it's the real, okay, I'm sorry, I misread that there. A is the real part, and then B always goes with the imaginary part. And then I guess here this is saying if a is equal to 0, so if you don't have an a part, but then you have a b part right there, if b is not 0, then that means it's purely an imaginary number. So anyways, let's talk about what you do here with complex numbers. You can add, subtract, multiply, and divide. I know the formatting here is a little bit weird, so I apologize here about this, but let's do this. I'll put the work, I guess, above the problem here. But it's real simple. All you're going to do here is just combine the reals with the reals and then the imaginaries with imaginaries. So it's just like combining like terms. We combine 12 and negative 8. That combines up to 4. Okay, and then you have the negative 11i and then the 3i right there. If you combine like terms, that's negative, I guess, 8i. And that's actually how you leave your answer right there. So all you're doing really is combining like terms. It's basically adding, like if you had a bunch of x's or something. So usually pretty straightforward. Now, if you have a parentheses and you have a negative outside the parentheses, usually we'd say it's a good idea to distribute into the parentheses. So that'd be minus 13 and then minus 4i and then plus that last I right there. And then I guess combining like terms here, I guess that's 22. And then combining your i's, that'll be minus 3i. And that'll be it right there. Okay. Next one here. This one's got a little bit of a tricky thing here. Which the first part doesn't start out bad. You're mostly all going to say that's 40i right there, negative 40i. And then plus 45, but then I times I is I squared. And then the one additional step you got to do, you always want to change an I squared to a negative 1. So this will become negative 40i and then plus 45 and then times negative 1. So basically it simplifies down to negative 45 and then minus 4 or 40i. And typically it's a good habit to write the imaginary part here second. That's the best practice. You might want to clarify with your teacher if that's something that they'll count off for or not. But make sure you write the real part first, or get in a habit of writing the real part first and then the imaginary part second. So let's try this last one here. So this last one, notice you got a binomial times a binomial. I guess I'll color code it here. No blue yet. No. Okay, so this is a binomial times a binomial. So this is kind of like a FOIL problem. First, after, and or last. So negative 8 times 4 right there. Those are the first two things. That's negative 16. Negative 8 times negative 7i is positive, 56i. 2i times 4 is plus 8i. And then 2i times negative 7 right there is negative, 14. And then I squared. There's that I squared again, so we got to be really careful there with that. So that'll be negative 16. When you add the 8, what's that get us? 64, 64i. And then minus 14i squared, which is basically now 14 times negative 1. And I have a lot of people just go and convert that to positive 1 in one step. They kind of do the I squared part in their head. If you want to do that, you can. So here's what it comes out to. It's plus 14. So if you want to skip that step, you definitely can. And then we'll write the real part first. That's negative 2 right there. And then the second part, plus 64i, I guess. And that is how you write your answers there. So you can FOIL, you can add, you can subtract. Just make sure you distribute your negatives if you subtract. And then if you FOIL, or if you get some type of I squared, make sure you change I squared to a negative 1. Okay. Next section here, we're dealing with complex conjugates here. So if two complex number in the form of a plus bi and a minus bi, these are called complex conjugates. The product of complex conjugates is always a real number without any imaginary part. So let me show you kind of what I mean here by that. So if you just FOIL it, like we did the last problem here, since you got a binomial times a binomial, 3 times 3, it's going to be 9. 3 times I is negative 3i. I times 3 is positive 3i. And then I times negative I is negative I squared. And then the 3 i's cancel each other out. And then the I squared minus the negative I squared is basically plus minus -1, which will basically change to +1. So that'll simplify all the way down to 10. So that's what happens when you have a conjugate right there. Okay, and we actually use conjugates. They're really helpful for simplifying down expressions. We're going to see that on the next page here, but we'll practice a little bit more foiling conjugates here on this page. So 4 times 4, that's going to be 16. 4 times 2i will be, I guess, 8i. -2 times 4i is -8i, so those will cancel out again. And then 2i times -2i is -4i, and then squared. Alright, and then combine your like terms, that's 16. The 8i's cancel out, and then that'll be +4, basically. Remember, your I squared is going to change to -1. And then -1 times 4 is going to be +4. And when you fully simplify, that'll be 20. And that is it there. Alright, last one here. I guess they put the I stuff first, that's fine. So 3i times 3i is 9i squared. 3i times -7 is -21i. And then you get +21i. And then -49. Okay, your i's should cancel out. Remember, I squared changes to -1, so that essentially becomes -9 right there. And then minus the other 49 that you had. And I guess -58 once you're done. So sometimes they can come out as positive. Or, I'm sorry, negative numbers. So that's that. Let's see what we got here. This last section here. You can use conjugates to write the quotient of complex numbers in the simplest form. This is very similar to what we use in the radicals in the denominator. Or warm-up. I guess we didn't do a warm-up there, but if we had a warm-up. So actually, I'm going to start us backwards here. I'm going to start out here with 5. Start out with 1. That's a little bit more tricky here. So I want to tie this directly into conjugates, and then we'll talk about why A was different. So anyways, to simplify, when you have division of complex numbers here, we use a conjugate to get rid of this denominator here. So we don't like things in the denominator, and we definitely don't like i's in the denominator. So we're going to multiply by 1 and then minus I, kind of like that right there. And then the same exact thing here in the numerator. So remember, with a fraction, if like you're trying to, like usually we use this process if we're trying to get a common denominator. So if you had like 1/2 and you wanted the denominator to be like 8, you can multiply the top and bottom by 4. That's technically multiplying by 1, which doesn't change anything. So we say like 4/8 is the same thing as 1/2. So this has got a lot of similarities here. The right-hand side is technically 1 right there. 1 minus I over 1 minus I. So that doesn't change the value, and that's why we can do this. But anyways, do you need to know that? No, you just need to know, okay, I need to multiply by the conjugate in the top and bottom to simplify. So here's what it looks like. Here in the bottom, you FOIL as normal. So 1 times 1 is 1. 1 times -I is -I. Positive I, and then -I squared. Now in the numerator, when you distribute 5 to everything, that's just going to be 5 and then minus 5i. Okay, now in the denominator, we need to start cleaning this up here. We have the i's that cancel each other out, and then remember, I squared, that's going to change to -1, and then if you have -1, that's going to be +1, and then 1 plus 1 it's going to be 2, or whoops, I guess, yeah, let's write it out like this here. We'll write it as 1 plus 1 in the denominator. Obviously, we can clean that up, so we're going to just write 2 overall in the denominator. Alright, and then some teachers will let you keep it like this here. I make my students split it up into 2 fractions here, so this is 5/2 and then minus 5i over 2, and that's how most of the times we're going to leave our answers there. So it's kind of weird at first here, so let me recap. We multiply by the conjugate in the top and bottom to cancel out all the i's in the bottom. We don't like when I is in the denominator of a fraction. Okay, we FOILed in the bottom and then we distributed in the top, just because that's what that called for there. Okay, and then we simplified our I squared. We got positive 1. We added that. We got 2. And then we split apart the fraction into 2 fractions. So let's try out another one since it's kind of a little tricky there. So we'll do C. C is a little bit more advanced here just because you got some i's in the numerator as well. But it should all work out good here. So you always multiply, though, when you're doing these, of the conjugate in the bottom or in the denominator of your fraction. So we'll go 5i, or 5 plus I, in the top and bottom here. Don't worry if anything doesn't cancel out in the numerator. We do not care if anything cancels out in the numerator. We want the things to cancel out in the denominator, which that's what we're designing this to do. So we do 5 times 5, that'll be 25. If you do 5 times I, that'll be 5i. Some people are going to skip this step once you get comfortable with it, and that should be fine. Negative 5i right there, and then negative I squared, all in the bottom. Okay, we're going to actually have to FOIL in the numerator, but not as much stuff is going to cancel out, so we just need to be a little bit careful here on this. So this will be 15. I guess this will be plus 3i. The insides will be plus 20i. And then the last will be plus 4i squared. So, pretty crazy. Got a lot of stuff going on here, so just one step at a time. I know my 5i's will cancel out. I know these I squareds are basically changed into negative 1. So that'll be, I guess, 15. Those two combine up to 23i. And then I guess we're going to have minus 4 because of the negative 1 times a positive 4. And if you want to simplify that in the same step, you can. All right, and the 5i's, they cancel out, so now this becomes 25, I guess, plus 1 right there. Okay, and then now combine up the numerators and denominators here, so that'll be 11 plus 23i. And then all over, I guess we had 26. And then split apart your fractions. Oh, whoops. So I'm going to write this as 11 over 26, and then 23i over 26. And then that will be your final answer right there. Okay, that'll be it. So let's do this last one here. The only thing that's kind of weird about this last one here is since you don't have a binomial, it's not really the greatest idea to talk about a conjugate. But if we want to cancel out an I in the top and bottom, we can just multiply by I in this case. And here's what I mean here. So I times I right here, obviously that'll make I squared, which will eventually eliminate our, i's in the denominator. Now, if you have I in the numerator, you need to make sure to distribute that in to the numerator right there. So that'll be 7i, and then plus, I guess, 2i squared. Okay, and then obviously the I squared in the numerator, that's going to change to negative 2, basically, after you multiply by the negative 1, and that's all over negative 4. Okay, and then now we're going to split apart our fraction. I'm actually going to rewrite the order. I'm going to go negative 2 over negative 4. And then I'm going to go minus, I guess, 7i over 4. Clean that I up. And I'm actually kind of glad we got to this one here because this has got a crucial thing here. You always reduce your fractions, and then you also always cancel out your negatives. So negative 2 over negative 4 will reduce to positive 1/2. And then 7i over 4 does not reduce. So you just write that. So always reduce your fractions. And actually I'm going to add one more example here at the bottom just to kind of re-emphasize the simplification. So there's those examples. So just add this wherever here. Let's make it, I don't know, like 30 plus 25i over, I don't know, 45. I'm just making this up here. So when you split apart your fractions, I want you to make sure you always, always, always reduce these. So if you have that right there, 30 over 45, I think those are both divisible by 15. So that'd be 2/3. 15 goes into 30 2 times, and then 15 goes into 45 3 times. And then the 25 over 45, those are both divisible by 5. So 5 goes in the 25 5 times, and then 5 goes in the 45 9 times. And we'll put the I. So make sure just to reduce your fractions. And then other than that, I believe that is it here for the lesson today.